Good morning, everybody, and welcome to the second edition of Steelman's Engage. Engage 2.0 focuses on evolving global steel industry dynamics, with the industry prioritizing decarbonization as the way forward. The series will zoom in on the challenges associated with global decarbonization measures in the iron and steel industry and what it would take to implement the energy transition in the industry. The agenda of Engage 2.0 is to understand the perspective of industry leaders on a broad spectrum of topics, ranging from iron ore, coal, and steel, identified for discussion, to enable our clients to have a better understanding on how each sector is likely to pan out in the near future. I am Nirmal Dev, Technology Editor, Steelman, your host for this session. To start with, I would like to thank the Ministry of Steel, Government of India, and the Indian Steel Association for extending their support to Engage 2.0, as well as NMDC and JSW Steel for sponsoring this brainstorming event. Today, our topic is decarbonizing iron making, hydrogen-based DRI in China and India. And we are pleased to welcome Mr. Praveen Chaturvedi, Vice President and Head, Sales Upstream India, Metals Division, Tenova Group. Welcome to Engage 2.0, Mr. Chaturvedi.
Yeah, thank you, Mr. Nirmala, for this initiative. And first of all, good morning to all of you. On behalf of Tenova Group, I would like to welcome you for this presentation. And we will thank Steel Mint Events for giving this opportunity to us. The topic, as you might have seen, it is mentioned hydrogen-based DRI, that is solution to decarbonize the iron making. And you might have seen the two words China and India. So this is my presentation. It will be. I'm now going to share.
Yeah. So before the sir starts off with his presentation, I would just like to give a brief introduction of Mr. Praveen Chaturvedi. Mr. Chaturvedi is associated with the iron and steel industry for almost 3 decades in various capacities. He graduated in mechanical engineering from NIT Rourkela and completed postgraduate studies from Symbiosis Pune. He's associated with Tenova for the last 10 years. Prior to joining Tenova Group, Mr. Chaturvedi has served in L&T, Ispat Industries Limited, and Jindal Shahid, Oman. His experience at Tenova involved active association with upstream products such as HYL DRP, Pyromet, and Melt Shops business units of Tenova. Mr. Chaturvedi, please go forward with your presentation, sir.
Thanks once again, Mr. Nirmala. So I'm now going to share my screen. You may just advise me if it is visible. Oops.
Yes, sir, it is visible to us.
Okay. Then I'll put in the, yeah. So now the full screen is visible, Mr. Nirmala?
Yes, sir, it is visible.
Okay, thank you once again. So coming to the topic, as you can see, this is hydrogen-based DRI, what we are referring to here, basically in terms of reducing the carbon footprints in iron and steel industry. So this is our basically the topic. And yeah, as I was mentioning that we have mentioned the two words in this topic, China and India. So with that reference, I'm going to just share the screen to you. As we all know, China is the world largest steel producer in the world, for sure. So my today's topic is more focused on this aspect, that whatever is happening in China can be adopted in India in terms of preparedness and adaptability for the future. That is more important. I want to talk about our various initiatives like hybrid also. I will touch upon about the hybrid, about the cell cost, MU-DRL, which has been done in Germany as well as in Sweden, and regarding our DRI, direct reduction technology. And more importantly, focus will be on the China, where we are already fit in to utilize up to 100% hydrogen. So that is the topic, just to make awareness and knowledge sharing in the presentation slides yet to come. Yeah, thanks. So starting from China, yes, you can see recently there is a newsletter in which Baosteel, they are going ahead with 1 million hydrogen based DRI plant. So now it is in the public, it is the domain, since we were discussing for last long time. And here I'm going to just share the some of the pre-cap slides in which we will explain more in the subsequent time in this presentation. Yeah, in this session. This is the first DRI production plant. And you see Baosteel is the largest steel manufacturer in the world. And they are moving ahead with this, going ahead with this DRI making, and that's true with the hydrogen. Of course, they are quite open, having the flexibility of using the natural gas as well as cocoa and gas. And thanks to our technology, that Baosteel, Baowu group, now is proceeding towards the reducing the carbon emission and carbon neutrality in 2050. And we are part of this journey. So this is about the China Baosteel. Coming to the another China DRI plant where we are associated with them. That was the first DRI plant in China, going to be commissioned in this year itself. That is going to be the first DRI production plant, which will be with hydrogen. You can see it's around 500,000 capacity. That is the steel maker is HBIS. HBIS also, you know, they are the third largest steel producer in the world. Number one is Baosteel. They are moving ahead with this DRI hydrogen-based technology, and as well as number three, HBIS. So awareness has already started, and not only awareness, they are implementing these projects in their country as a part of their sustainability philosophy. Now, yes, so before China, already we have implemented such projects in Salzgitter. Salzgitter, it is in Germany, where we are already doing project for them for using 100% hydrogen. I'm going to explain more in this. That is basically part of Salzgitter low cost steel making, that is in Germany. I'll explain you in all these slides. I'm going to explain in the subsequent session, in the subsequent time. Yeah. Then hybrid. I think this you might be hearing in the recent news about the hybrid. This is in Sweden, done by SSAB. This is fossil fuel steel, the world first fossil fuel steel making plant. And Tenova, we are proud to be partner of this mission. Now the plant is in operation in Sweden. Yes, you can see the fossil fuel steel in actual. It is not in concept, not in paper, but in actual, it has been prepared. SSAB, fossil fuel steel, where we have supplied our DRI plant. Now, so who we are, just to give you a brief introduction. Tenova, basically we are part of Techint group. I'm just putting on the laser mode. Yeah. So you can see we are having 17.5 million of 70.5 billion annual revenue. More importantly, why I'm showing this slide, I'm not going to promote about our company, just to make you aware that Tenova is part of Techint group, wherein you will find the major component in terms of sales, that is Tenaris and Ternium. Tenaris and Ternium, they are basically our steel making group. Tenaris makes around 8.5 million ton of seamless pipe, and Ternium for the flat product around 12.5 million ton. So yes, you can say that yes, we are part of the steel making group, and we know how the steel is made. So this is basically giving you an idea about what Tenaris and Ternium and the Techint group is. Then in terms of sustainability champions, which was declared by World Steel Association, here you can also find, along with other sustainable champions, our group company, Tenaris and Ternium, they are also featuring here. Above that, recently, I think last week you might have read that World Steel Association, they have recognized 39 steel producers who are engaged in sustainability program, and many in fact all these steel makers, they have signed as a part of sustainable charter. They are the member of that one, because they are focused on these pillars. Of course, that is available in the World Steel Association site. And here you will find that signature from our Tenaris and Ternium is also appearing. So what we mean to say that since we are part of our Techint group, which is they themselves produce the steel in a sustainable way, and we are associated with it. So we know how the sustainability plays a very important role as a Tenova individually, if you ask us. So who are Tenova? Just I'm taking one slide and then we'll jump to the main topic. We provide sustainable solution for metal as well as mining. So this is what we are part of the group where we focus on the sustainability. And considering the sustainability, we have come up with a new phrase, sustainability, where you will find that Tenova is appearing in that sustainability approach. So this is our mantra, and we focus this in that for the sustainability, Tenova, we are part of that one. So that is what we are developed a new word, sustainability. Yeah, we are having worldwide presence, not only in India, of course, India in all these cities, major cities, Mumbai, Chennai, Calcutta, Bengaluru, and China also we are focused. So right now in this presentation, I'm going to focus about the China and India because the topic is like that. But we are basically, our head office is located in Italy, Milan, and worldwide we are present. So this is our global presence. And these are some of the brands which are associated with us. Here, what we will be discussing about HYL technology, which are associated with DRI making. Of course, we have got our downstream facilities like Italian Pianti and Omni roll grinders, and we are into the strip processing. So anyway, those are our various groups. So the main focus here will be our HYL technology, which is owned by us. And we will be discussing on this about the DRI making. Yeah, as I told you that I belong to the metal division and upstream division. So we are into the metal making, hot formed, cold rolling mill, strip processing, aluminum, and we are into hydro and pyrometallurgy also. Now, coming to again the topic, that is the DRI. DRI. So some basic concept of DRI making, I'm just going to touch upon, because in India, you know, there are a lot of coal-based DRI also, there is blast furnace route also, there are other routes also. So I'm just going to touch upon a very basic chemistry, what we have learned in our elementary schools. Reduction with the coal. Reduction means reduction of iron oxide. So this is a typical example of a blast furnace in which they are more into the coal. That is why you might be hearing that most of the country, they are eliminating blast furnace route and going ahead with the, whether it is scrap route or DRI route. Why? The main reason is in order to reduce the footprint. You see, carbon is converted into carbon monoxide. So this carbon monoxide acts as a reducing agent. Reducing means reduction of the iron oxide from Fe2O3 or Fe3O4. We are reducing it to Fe and CO2. So at the end of the day, what we are producing is apart from iron, of course, we are also generating CO2, 100% CO2. Why? Because we are using carbon monoxide as a reducing agent. Unlike that, in natural gas, if you are using in a DRI, typical DRI plant, considering the natural gas, if you see natural gas, methane is getting broken down into carbon monoxide and hydrogen. Here you will find hydrogen is also coming into the picture for reduction. Carbon monoxide and hydrogen, both are coming into the picture. And at the end of the day, in such type of process, where DRI plant, we are putting the iron ore and getting the DRI. Of course, there is no coal. They are using the methane coming from the natural gas for making these two reducing gases. And at the end of the day, you are finding CO2 as well as H2O, water. You will find in all these things, apart from iron, after the reduction, you are finding carbon dioxide and water. So we can say that 50% there is a reduction in the CO2 as compared to blast furnace. But our aim is not to stop at 50% of the carbon reduction. We should go with the zero emission. And that is the main concept what we are discussing in this forum. Now here hydrogen comes into the picture. Hydrogen, if we generate it, I'm talking of green hydrogen. I'm talking of, again, I'm repeating, I'm talking of the green hydrogen, which can be obtained from electrolysis by water. And you can see we can produce oxygen as well as hydrogen. And this hydrogen is used for making the reduction of the iron oxide. And finally, what we are getting is only water. So this should be our mission. This is our mission for the zero carbon we can achieve from hydrogen if we are doing it through electrolysis. So this is our DRI plant. Now, why we are talking about steel plant? Because as you know, and it is a known fact that the steel plant, they account for 7% of the total greenhouse gas emission. So definitely 7% is not less. So we should focus on this. So that is the main concept here. Now, this chart you can see. This slide gives you the basic overall view of the decarbonization steps, what we have to follow. In the top vertex of this triangle, you will find the carbon, and in the downside, on the right side, on the left side, you are finding hydrogen. So the aim is to move from the carbon to hydrogen. This is called decarbonization, but it cannot be done in a single attempt. It has to be done in various steps. Initially, you can see here, when it is based on the carbon, of course, coke and coal are used for making the blast furnace route. Yes, there are systems for the carbon, smart carbon usage or smart carbon utilization. That is what people are doing, because those things we can store and utilize it in blast furnace route, as well as also then we go further down. Then there is a DRI, which is based on natural gas or syngas or whatever the gases are available. This is the DRI. So we are furthermore 50% CO2 is getting reduced in this stage. Rather than coke, it is substituted by the natural gas or any other gas, reducing gas, which will reduce the iron oxide. Then finally, coming down, it is hydrogen. Here, the aim is direct carbon avoidance, carbon direct avoidance, rather than capturing and utilizing. Why not to focus on zero carbon effect? That is, avoid the carbon from the source itself. And that is how the hydrogen comes into the picture. And hydrogen, we are referring to green hydrogen. What is meant by green hydrogen? The hydrogen which are generated from the renewable energy for generating the electricity, and that electricity goes into the water and to generate the hydrogen. So that is the concept we are moving ahead. Of course, there is electric arc furnace which use electricity. That is also electricity if we can generate from electrolysis. That is another topic which we can discuss. Now, the main question is how to make steel in future. On this slide, you can see our understanding for the steel making process based on conventional iron making route, DRI and EAF, using natural gas in the present scenario, but that are also open to take hydrogen if available, and it will replace the methane. And in our DRI model, in the next slide, I'll just show you whether it is natural gas or hydrogen, it hardly makes any difference, because these two gases are acting as a reducing agent, as I have shown you in the previous chemical equations. The iron is getting reduced, and that can be melted in as a steel making. So hydrogen, if available, we can substitute the natural gas. And hydrogen, how it is getting generated, the main thrust should be renewable energy. That is more important, whether it is windmill or solar. So we generate the electricity, and in the electrolyzer, convert the water into oxygen and hydrogen and make a green steel. So the main theme here is that we should be ready with the flexibility of having whatever reducing gases are available, and our adaptability and preparedness for the future. That is more important, which China, they are already on this path. Now, in this slide, you can see there is blast furnace BOF route. And it is a known fact that in the blast furnace BOF route, we can make high grade as well as low grade steel, whether it is for the long product or whether it is for the flat product. So this is known fact. But in between, we are talking about the hot metal and the DRI. But there is also scrap. Scrap is also, most of the countries, they are using it. But with the scrap, there is a challenge that you can make low grade. For making the high grade, you need some virgin source like pig iron or DRI or HBI, some virgin source you need to make a high grade steel, whether it in the long product or high flat product. So if you are installing, if one is installing DRI, it can cater both long as well as short product for the low and high grade. So it can be a substitution to BF if you are opting DRI being a virgin source. Now, so this was about the brief about the chemical scenario, economic scenario, market scenario, how we can move ahead for the DRI making based on hydrogen. Here you can see this is our HYL DRI technology, jointly developed by Tenova and Denali, and this is what we are going to just brief you in the next slide. Yeah, here you may observe that. Oops, sorry. Here you may observe there is selective removal of the CO2, because if you are using natural gas, definitely there will be CO2. As I mentioned you, 50% of the CO2 will be there and 50% water. So 50% CO2 also we are not releasing into the atmosphere. Here the carbon capture unit and carbon capture storage, smart carbon storage units comes with the picture. In our system, this is our DRI plant. I'll just explain you. This is our DRI plant. We put the iron ore and finally we get either cold DRI or HBI or hot DRI into the adjacent electric arc furnace. And nowadays trend is to make pig iron. This is a substitute to blast furnace, alternate route of making the hot metal. You put the DRI, and the DRI what we are getting in our furnaces, in our module, DR module, in HOL module, it is high carbon DRI. The high carbon DRI means 1.5, it goes up to 5%. So if you are using 4% or 3.8% or 4.2% of carbon, it's very good. If you install a OSBF, open slack bath furnace, this is basically a type of DRI melter in a reduced atmosphere, and we get the hot metal exactly similar composition of the blast furnace. So this is also, I will just touch upon how we can make the pig iron hot metal, because most of the customer, they want to retain their BOF facilities, LD converters. So for them, if they install the DRI, they can retain all their downstream facilities. No need of installing the electric arc furnace. So this is also very good concept the people are following across the globe. I'll just take a few slides in mentioning those things. Now, coming to the flexibility. Flexibility, whether it is natural gas or reformed gas, syngas, coke gas, hydrogen, shale gas, CBM, whatever the gases are available, these are reducing gas. In our DRI plant, you plug it, serve it, and you are making the reduction process. In any proportion, whether it is 100% natural gas or 100% reformed or maybe 50-50 or 20-80, whatever may be, whatever you give the gases, our system remain the same scheme with whatever sources are available. Our equipment is ready to operate. And this is our process gas heater. Our reactor, it works in a high pressure, 6 to 8 bar, and high temperature. And we don't require any reformer, nothing, very small, compact system. Yes, here CO2 removal system, as I was mentioning, that inherently we remove the CO2. That is very, very important, because if you are using the methane, of course, with hydrogen, there won't be any CO2 generation. But in case of methane or in case of coke gas or any gases, then there will be some CO2 generation. Then what we are doing through selective removal system, we are removing 60% of the CO2 which is getting generated in the system, and this CO2 gives added value to you as a byproduct, and it can be used for food and beverage industries, production of dry ice. It can be pumped into the oil wells for boosting the oil production, like the people in Emirates Steel, they are doing it. So these are the some companies, Ternium and Tenaris, we are selling it to the Linde and other companies for food and beverage industries. Indonesia, they are using for food industries. In JSW Salau in India, it has been the CO2, those are sold to Air Liquid for making the dry ice. Emirates Steel, as I mentioned you, for the enhanced oil recovery. So whatever CO2 is generated, we are not emitting it to the atmosphere, we are capturing it and utilizing it properly. Now, pig iron production via DRI plant, that is what I was just mentioning you before. Yes, the more important here is that you can find here their DRI plant. clubbed with open slag bath furnace. This is a reducing furnace beneath it. What is the advantage of this? That the one feature is that we are producing high carbon DRI on the top. In our system, we produce high carbon DRI more than 4%. And there is a reducing arc furnace. Basically, it is a submerged arc furnace. It appears it looks like submerged arc furnace, but we work in a brush arc mode. Basically, it does the reduction of it basically helps us to melt the DRI from 600 degrees to 1400 degrees centigrade, whatever is the blast furnace hot metal, and it can be poured directly to the torpedo ladle. And the other advantage is that we can maintain the BOF facility in the downstream. Just we have to replace the blast furnace. No need of occupying more space. Everything is happening in a vertical chamber. And very important factor here is we are not depending on the DR grade pellet. BF grade pellet can be very easily it can be utilized. So we are not requesting for any DR grade pellet. Only the BF grade pellet, low cost pellet can be utilized. Why? Because the ganges, whatever is coming, it can be removed in our open slag furnace. OSBF, open slag bath furnace, we call it open slag bath furnace. And the slag also what we get can be used just like in blast furnace in the concrete industries. Coming more into this concept, pig iron production via DRI. Here you can see the real plant. The DRI is on the top and OSBF, open slag bath furnace, in the bottom. This is here there is a provision for removing the slag, and you just like in blast furnace we can remove the slag, and we can also tap the hot metal in the torpedo ladle, which can be utilized in the existing downstream facility. So that there are various advantages of this type of furnace. You don't need such a big transformer as compared to electric arc furnace, DRI and electric arc furnace route, wherein you need a high transformer, flicker, then SVC. Those things are not required. This is why look, it appears like a submerged arc furnace having the Soderberg paste electrode. We are using the refractory life also lasts up to 5 to 10 years. Unlike in electric arc furnaces, building is very small. There is no building as such. It is installed just beneath the DRI plant. So yeah, so this is one of the concept already being implemented various places. Hydrogen-based DRI. Now we are coming back to the topic. Carbon capture unit utilization, carbon capture utilization, or carbon capture storage, whatever it may be. Our aim should be carbon direct avoidance. Directly we have to avoid the carbon. So you can see this is the DRI plant. As a reducing agent, what we are using is hydrogen, pure hydrogen. Hydrogen, how it is getting generated? From electrolysis. Electrolysis, how we are getting the electrical energy? That is from the renewable energy. We are not using any thermal energy. And this is the scheme what we have just explained to you, that we can be able to make whether it is cold DRI, HBI, hot DRI, or pig iron. Yeah, this should be our vision. DRI plant clubbed with the solar panel and the windmill, and we generate the electricity, and that electricity can be used. So this is a total iron making facility. This is a process gas heater, and this is basically our DRI tower. Experience of using hydrogen. Then you may ask that what is the experience of using energy in our HYL technology? See, we have been using this by even if it is methane, then also we are using hydrogen as our reducing agent as compared to carbon monoxide. So the more the hydrogen, the more happier person we are as a technology supplier, as a process maker. So the same scheme can be also fitted with high hydrogen. You see here we have done in 90s, some 30 years ago. With 90% hydrogen we trial and tested, well proven, not an issue. That is why what we are thinking now, hydrogen, that we have already done long ago as a pilot test, and it is quite successful, and that is why we are available in the market for using this type of hydrogen based DRI. I'll explain you what is the advantage of hydrogen as compared to carbon monoxide. Of course, carbon monoxide generates CO2, but hydrogen doesn't generate any CO2. Here, from energy balance point of view, because see, there are two reducing agents if you are reducing these gases. One is either hydrogen or carbon monoxide. But with hydrogen, The reaction, the other advantage apart from generating the CO2, the other advantage is the reaction is very fast. Hydrogen with hydrogen. If hydrogen reduces iron oxide, it is 4 times faster than as compared to carbon monoxide, compared to the carbon monoxide. So that is why we are able to utilize the more hydrogen as a reducing, because our purpose is to reduce the iron oxide, and that is what we are doing. Yes, I was mentioning about the pilot plant, what we have been doing in the past in 1990s. This is the actual plant. We did it, pilot plant. We say pilot plant, but it is not on the lab scale. It's an actual plant. We installed it and we tried it in 90s for 90% hydrogen. We did everything. We made it, and now the same concept is being adopted at various steel makers. It is more efficient because we are working at high pressure as compared to the other technology which is available in the market for the gas-based DRI. Here, basically, in our system, we are working at high pressure. The reactor itself is a pressurized one, 8 bar, as compared to the other technology which is available in the market of 1.5 bar. So with high pressure, you get high temperature also, definitely. The equipment is very less, and more important is that we are able to use very less electrical energy as compared to the system which are available in the market, which works in the low pressure system. So that is why OPEX is also very, very less as compared to. Even furthermore, if we are using hydrogen in the same proportion, it is much better as compared to the natural gas, the energy consumption. So in this slide, this is what we are showing. This is energy benefit of the energy in terms of switching from natural gas to the hydrogen. Because in China or wherever we are installing this plant, those plants are equipped with to use either 100% nitrogen, 100% natural gas to any proportion, 35%, 55%, and gradually to 100% hydrogen, and vice versa, hydrogen to natural gas and natural gas to hydrogen, or any combination of any gases. But if you are using more hydrogen, then energy consumption will be very less. So this is what we are trying to show here. And coming to the CO2 emission, definitely there is a benefit if we switch from natural gas to hydrogen, and that hydrogen from the green hydrogen, then it is called zero carbon emission. Now, the moment I am talking about hydrogen and electrolyzer, see, we are not electrolyzer manufacturer, but since we have worked with various companies who are into the business, this is what in this chart we are showing. This is the DRI production from 0.25 million to 2.5. Our DRI module ranges from small micro modules, that is 0.25 million ton per annum, goes up to maximum 2.5 million ton per annum. So with all the DRI, with various DRI modules capacity wise, we have just evaluated how much hydrogen will be required. And for generating that hydrogen, whether it is for 55% or 70% hydrogen or even 100% hydrogen, what will be the electrolyzer required in terms of megawatt, that also is listed here. So you can just have an idea that around how much hydrogen is needed to make 1 ton of DRI. This may be your question. Yes, for making 1 ton of DRI, we need approximately for the reduction purpose, that is around 50 to 55 kg of hydrogen. That is something equivalent to 600 nm cube of hydrogen. And another question may come up, for generating 1 kg of hydrogen, how much electrical energy is needed at the moment at the electrolyzer? That comes out to roughly around 40 kilowatt hour. 40 kilowatt. So you can see it is not less. We need a huge electrical energy to do the hydrogen generation. But anyway, people are working on it, and the day will definitely come when the hydrogen production will be much more economical. But this is going to be a future. Here we are talking about the green electricity. If we are do it from green electricity, it is much more beneficial. So whatever I am telling, it is not only on the paper, but already implemented. Use of hydrogen projects, you can see, which are already under execution. CellCos, that is Cellskeeter, which I was mentioning. You can see this is the transformation process up to 2050. Presently, they have blast furnace and converter. They are switching over to electrolyzer and DRI, and then in a phased manner, they will move ahead with reduction of around 92 to 95% CO2. We cannot say 100%. Of course, it is tends to 100%, but definitely there will be some carbon emission. But that also it's huge if we are able to reduce to 90 or 95% of CO2 emission. And this is another. This is in Germany. And this is a hybrid project. Of course, this you might be aware of that SSAB and LKB and Wet and Wall, they have done it. Inside, you will find our DRI plant, which is installed. Hydrogen is being generated by other agency that has been given to us, and we have supplied our DRI plant to convert iron oxide into iron, introducing it. This is mu DRL. Again, this is based on 100% hydrogen. This is based on 100% hydrogen, this plant. This is also in execution phase, will be completed by within this year, within this mid of this year. I think this summer we will be able to get the result out of it. This is in Salzgitter, the same. This is a demonstration plant for Salcos. Yeah, this Salcos which I was mentioning, yeah, this is the same elaboration what I did, that in a gradual way they are switching from blast furnace BUF to DRI EF. Of course, you will find the electrolyzer here. Once it get implemented, they will switch over to the 100% hydrogen based. So Salcos approach, I'm just mentioning further more slides on this. Conventional coal based BF route. Why I'm referring to Salcos? Because the same philosophy is now being adopted by China. These two plants which I was mentioning. Conventional coal based BF route, because in China also, right now, these two steel makers which I have shown, they are making mainly the steel through BF and BF route, and it is accounting to 1.6 ton CO2 is generated per ton of the liquid steel. Of course, for Indian case, it is, I think, more. It is something around 2.2 ton. Anyway, considering this German plant, presently, you can see the blast furnace route. This is the green line, what we have shown here. So this green arrow, you can see iron pellets, coke is going into the blast furnace converter, and they're making the steel out of it. What is going to be the future? The shifting and the transformation process will be from BF to DR, gas-based DRI route, to reduce the emission to 90%. How? You see the blue, dark blue line, that is direct reduction. This is, you install the DRI plant, install the electric arc furnace, and make the steel out of it. Downstream facility will remain the same. And this can utilize natural gas, as I mentioned you, or it can also use the hydrogen in any proportion. The hydrogen which is generated, it is from the green electricity. So this is the approach of the Salcos. So in Salcos, if you see, there are a lot of agencies involved here. Our part is to generate the DRI, to make the DRI plant. And there are other agencies, they are involved for the electrolyzer and wind energy, solar energy, how to convert into electricity, and those electricity into the electrolyzer. So there are various agencies involved in the Salcos project. Yeah, this was I was mentioning about the same Salcos. They are also doing a project parallelly for the mu DRL, that is the demonstration plant, which I was mentioning, that they will use 100% hydrogen already in execution phase, and we hope that this will start in the summer of this year itself. So in a nutshell, back to Salcos, you see that here there is a DRI plant, and with the best available technology, it is equipped with running with the natural gas and or with the green hydrogen, and we are making, and so this is basically a part of the carbon direct avoidance. Yeah, they have made the calculation just to make aware how the German cases, whatever they are generating, the capacity is 10 million ton steel they make, and whatever, if they implement this Salcos project, they will save the emission equivalent to 4.6 million of car. That is roughly around 10% of the German car, those who are emitting the emission, and equivalent to the CO2 absorbed by 500 million trees which is 6.6 times the Berlin city. So this is only to give you a picture that how carbon footprint reduction will benefit a common people in terms of understanding that what will be the implication. Yeah, this is the hybrid project. As I mentioned you, this is, you might have seen in the recent news. The aim is to replace the coking coal with the hydrogen, and the main effort is to reduce the CO2 and decarbonize the steel industry. This is the project of the Sweden, already commissioned, already in production. And you might have seen that the small sample which I have shown you in the previous slide. And inside there is a DRI plant, and we are supplying our DRI plant. So there is no carbon footprint. Plant is now in operation. Yeah. So this is one of the plant in Russia. This is the greenest DRI plant in Russia, now in implementation. This is big plant, 2.5 million ton. And it is already fitted with CO2 removal system, which will reduce the carbon footprint by 64%. It is already in execution phase. Of course, from Russia, I think we should quickly jump to again back to China, because Russia is already in the news. So anyway, coming back to China. So yeah, coming back to China, the world first DRI plant, as I have mentioned you, already they are implementing it, and we see that this plant will be in operation in 2022. This is HBIS group. This is the third world largest steel producer, HBIS. So again, so this is what I'm just trying to say, that whether it is natural gas or hydrogen, our DRI is capable to make the steel. So this is the main aim of showing this slide. Coming back to the hot metal, just to give you the basic idea how we are talking about the replacing the blast furnace with the DRI. This is the DRI. We are making the high carbon DRI. That is if you are using the natural gas, 4 to 5% of the carbon. Then this high carbon DRI at 600 degree will be melted in our OSBF. Either you can put in an electric arc furnace, or you can use it in the OSBF. The advantage of OSBF is that it will remove the slag, all the silica and whatever is coming in the iron ore. That is the PF grade pellet, or even the low grade pellet, we can use it. So we are not bothered about how much gang is there, because we are doing the adjustment here. We are also doing the adjustment of the carbon here. Of course, when it is 4 to 5% carbon, then we are very happy. But if we are replacing this nitrogen with hydrogen, then there won't be any carbon in the DRI. We can add the carbon in the DRI in OSBF to maintain the same consistency of the hot metal which we are coming in. And downstream, you can use the BOF or LD shop, which is already prevailing. For example, just to give you much more idea on this, reducing the carbon footprint. Normally pellets, of course, that is required. So existing practice normally nowadays, that whatever pellets are there, we install the blast furnace, and then it goes into the BOF. But with DRI and OSBF, use the same pellet in the sense that BF grade pellet. We are not asking for the DR grade pellet, costly pellet. Use in the DRI plant, melt in our OSBF, make the same chemistry of 4.5% plus minus whatever is you are getting from the hot metal, pour in the same torpedo ladle, and use in the same downstream facility for making the steel. In this process, you are reducing 50% CO2 emission if we are switching over from coal to, here I am referring example of natural gas as a reducing gas. But if you go with the hydrogen, of course, we have to see the economics of the hydrogen, at what rate hydrogen is available. And then there will be 95% reduction in the CO2 emission. So normally scrap, again, I'm coming back to the scrap. Scrap, if you are having, as you know, we have the technology of melting the scrap in our electric arc furnace called con steel. So this is a way to reach the carbon neutrality. Already China, they have been in this journey for last 20-25 years. So in China, you know, there are either hot metal, means blast furnace, or scrap. So they play between the two. So there we have got more than 60 installation of such con steel electric arc furnaces in China. And now they are switching from scrap DRI to scrap route to, they are moving to iron ore using the DRI, hydrogen-based DRI. Already these two large steel players like HBIS and Baosteel, they are already on the job. install the OSBF, or you can put a typical electric arc furnace, and from OSBF you can make the hot metal and it goes into the BOF, or else you can install electric arc furnace. There is one more furnace concept which we can discuss in separate forum, that is called Flexi modular furnace. That is also quite commonly available we have supplied in China. They are using that the furnace, Flexi modular furnace, they have got flexibility in terms of charge mix, whether it is a DRI or hot metal or scrap, in whatever composition, in whatever proportion it is available, we are able to make the steel out of it. So it can work in a BOF mode as a converter mode, or it can also work in a typical electric arc furnace mode. So that is called, we call it Flexi modular furnace. Anyway, I'm just moving to the another slide. The concept what I have mentioned, that making the pig iron from the DRI is already in implementation. It is not in paper. So you can see this is the first nodular pig iron plant in USA. In Patmin is the customer. It is going to be commissioned in this month. This year, not this month. I have to just check it out. What is the status of this plant? And it is there. It will produce 500,000 of pig iron. Same the process of DRI and OSBF, and we are making the pig iron out of it. There is yet another plant in Black Rock in Canada, Quebec. They have also installed the same plant, the DRI presently with natural gas, and they are also ready to switch over to hydrogen to make the pig iron, high purity pig iron, the same DRI and OSBF, and make the pig iron out of it. So this is the project already in the completion phase. We have to just check what is the status. And now coming back to HBIS again, I am just showing the HBIS and Baosteel, as I mentioned you in my last slide, previous slide, that the Baosteel, they have given us the order for installing the DRI plant, and this is going to be the 1 million ton DRI plant for reducing the carbon emission system. And these are also fitted to use hydrogen, natural gas, cocoa gas, whatever gas is available, but it is designed for the hydrogen. So thanks. This is my presentation in nutshell. I think I have completed in 45 minutes what Mr. Nirmala has given me, the time slot. And if any question, you just you can.
Thank you, sir. A very comprehensive presentation. I have one or two quick questions that I want to ask you. First of all, it's a very interesting thing that we are combining pig iron with DRI, and we are dispensing with blast furnace. But in China, as we know that there was a recent study by BHP showing that the comparative age of blast furnaces in China and India is much less than in Europe and other parts of the world. So actually in China, the average age is about 12-13 years, while in India, it's about 18-20 years. So the huge investments that have come for new blast furnace building in China also. So how does it fit with DRI and this dispensing with blast furnaces and mixing BOF directly with DRI? So do you think that now that so much investments have already come into blast furnaces, how long it could take to China? It could take for China to gradually move over to DRI.
Very, very good question. And I'm again thanking you for taking this subject, China and India. So what China has already thought, calculated, evaluated, and now they are in the implementing phase. So we can learn from the experiences, what they did, their homework in the sense, Baosteel as well as HBIS, they are very, very, very big companies. They make, I think Baosteel makes something 115 million per annum, I think equivalent to what we India in totality make. So if they are doing it, definitely they might have done some exercise. Of course, we have done it for various other steel customers also, not an issue. So they have come to this conclusion, and that is the reason why they are switching over to this DRI with hydrogen provision, of course, with hydrogen and with the provision of the natural gas and cocoa gas, whatever is available, including HBIS also they make, I think, something around 50 million, something like that they make it. So they have done the exercise, and I telling you just now in this moment, it needs a lot of time to discuss on it. We have got various calculations in which you can know that what is the costing they are coming up. Definitely they have done their job. And more important thing is that they are prepared for the future and they are adapting that one. You know, in China, they were mainly playing between this, as I told you, scrap and hot metal. There was, so far we haven't heard of any DRI plant in China, but if they are coming up, definitely they have done the exercise. Definitely we can have a session on this, particular session on this. What is the costing of how much DRI route will cost? Because nobody will make steel at a higher capacity, a higher cost, because they have to sustain. And you know, China, they are quite cheap in making this steel. So what exercise homework they have done it, let us learn from them. And this is a type of awareness or knowledge sharing which we are addressing in this session. Sure. And another challenge for India is natural gas is not available in India, as you know. And yes, there are some opportunities also. Like we can think of CBM. I think CBM is also available, but at what cost? At what is the this transportation and distribution? That is also has to be addressed. And you know, already this natural gas line has been laid in most part of the cities, but I don't know when it will be available and at what rate. So rather than depending on that, we can at least start the exercise of generating the hydrogen. Of course, that is not economical, but from a pilot scale level, maybe 1 ton per hour DR plant, or maybe 100 kg per hour DR plant, very small module, one can try at least. And then it can be scaled up. So that thrust has to come from various customers as well as from the government to be ready with the future. So that is the thing which we have to look into.
Sure, sir. And that you rightly mentioned about DRI fuel, the kind of fuel that should be there. So, like we are, if natural gas is not available, because I'm now talking about the Indian context and moving a little away from the China context, where we know that huge rotary kilns are still there, and that is the infrastructure. And for coal-based DRI in the world, and India is the predominant producer. Where so, sir, what could be the cost of conversion to I'm just asking for an estimate. Or what could be the cost of conversion for such plants that are dependent on non-coking coal and mainly carbon monoxide for reduction in rotary kilns to shaft furnaces and fluidized beds and all that. So what could be the cost of conversion in terms of engineering, in terms of design, in terms of rebuilding infrastructure for DRI?
Sorry, I was muted. As I mentioned you, yeah, thank you. As I mentioned you, that our DRI, smallest module, the gas-based DRI, it is 0.2 million ton. That is quite small per hour. And yeah, as I mentioned you, that it can take any gas, whether it is coal gasification, as I mentioned you, that is also quite relevant in India. Coal to gas and syngas can be utilized. Because in our DRI you can put any gas, irrespective of whatever is available. Any reducing gas, like even Coke gas, if it is available in house, it is better to generate metallics by using in the DRI rather than making the electricity. So that calculation has been also done by many customers. I can share you those comparison between Coke gas to making the power, and Coke gas using to as a replacement to fuel, and Coke gas using for generating the metallics through DRI. So those things has already some exercise we have already done. And yes, the gas is a big challenge here. So coming back to the rotary kiln, there can be one possibility. We did 2 years back some study where the coal-based DRI can be melted in our open slag bath furnace. Instead of high carbon DRI, the coal-based DRI having the low carbon can be melted in our open slag bath furnace, number one. And number two, for adjusting the carbon, we can pump some carbon there and we can attain up to 3.8% or 4% carbon in the liquid steel. Sorry, liquid hot metal. That will be liquid hot metal, and that can go to the BOF, because BOF is not generating any CO2, because we are not using electricity. We are using only the oxygen. So BOF, there is no problem in BOF. BOF is very good, but the main challenge comes when we are using the coal-based DRI, and when we are coming to blast furnace, which they are using the coke. So those are carbon-intensive technologies. So that is the one of the way one can look into. Yeah, I agree with you.
Yes, sir. And sir, one very important question. This is my last question before I take one or two questions from the audience as well. Sir, the electrolysis infrastructure. Even I was, reading in China when we're talking about hydrogen, and slowly going from gray to green hydrogen. So, sir, the electrolysis infrastructure in China, because it is still not connected to the grid, and there are the infrastructure for transmission lines. So it will take China. China has given a date of 2050, 2060 for zero carbon. So it will take a long time also. In India, how do you see the context that the electrolysis infrastructure and splitting, generating hydrogen with the byproduct is water, and the electrolysis infrastructure, how with the government's new hydrogen policy also, what is the way forward? How long will it take India, to generate enough hydrogen to produce DRI?
Very, very relevant question. And I think this question can't be answered alone by me in this forum, nor our company, because hydrogen generation is not our forte. We are basically dependent, whoever is giving us hydrogen, we can reduce the iron oxide. But as you know, yes, that is a big thing which we have to focus. And as I told you, that we need 55 kg of hydrogen. We need 55 kg of hydrogen for generating 1 ton of DRI. It's a huge. And for generating 1 kg of hydrogen, you need around 40 kilowatt hours. So huge energy is required. So we cannot put thermal energy, then it will be of no use. And electrolyzer, yeah, there are many agencies which are there in the market who can scale up, like the people are doing in China also. They are also generating electrolyzer of their own. So that has to be really focused by, but these moves are coming from the government rather than any private players or public players. From the government, they are coming up with pilot plants, like in Sweden, like in Germany, like in China, like in many other part of the world. They are coming up with such pilot projects, and then once you get the confidence, and then you can scale up. So yes, it should be a public-private partnership type of thing that has to come up from the ministry level, and some incentives should be given. So this is what my request will be through you to the Ministry of Steel, who are also supporting this forum.
Absolutely, sir. There's still a long way to go for generation of enough hydrogen. So one of the questions that I would like to, one of the very interesting questions, in fact, being put up by a member of the audience, but he or she has not mentioned the name of the company, so it's just an anonymous question. Can hydrogen-based DRI be integrated with the induction furnace that is currently there in India today?
See, it is a DRI, so it can be used in the downstream facility. It can be used as a metallics. It is a metallics, so it can be used anywhere. Yeah, for sure. Why not?
So there is no technical problem.
No, there is no problem, because it is just a metallics. But hydrogen-based DRI, the only challenge will be that there won't be any. If you are using 100% hydrogen, there won't be any carbon. So if you want to adjust the carbon, so that also can be done. Can also be done. Not an issue. We can pump some combustible fuel, and we generate the carbon composition. We can increase it. But yes, it is just like a metallics. So no specific reason why it cannot be used in BOF as a chiller, or it cannot be used in induction furnace, or even for the arc furnaces. Not an issue.
Yes, sir. And so there's another, corresponding question, that we know that there are huge challenges associated with storage of hydrogen and transportation of hydrogen. So can you throw some light on this, that what developments are there in India, as far as storage and transportation of hydrogen are concerned?
That is a big challenge. Yes. So I cannot address on this hydrogen part, because literally it is people are working on it, and on a larger scale. I think some expert may tell about the hydrogen generation and storage and transportation. Yes, that has to be addressed. Yeah, agreed.
Yes, sir. And sir, one last question. The technological developments that we are seeing in DRI. These developments will also, because this is something that we all want to know, that these developments will also come to India. So could you give us an expected timeline as to how long it could take to change the current, predominantly thermal processes with new gas-based processes and less emissions? Just a broad timeline. So India's pledge at the Glasgow conference. So will India be able to fulfill it, given the steel industry's current standing?
I'm optimistic. I'm optimistic. And as saying goes, Rome was not built in a day, but one day it was made. So we cannot expect any drastic change in a short term, but at least there should be some startup. As we say, begin well, half done. So if we do with a proper thought, like Chinese, they are doing it, installing the DRI plant with hydrogen based. So it will become economical and reality and a future. And a future. So this is what I would say.
Absolutely,
Yes.
sir. Absolutely. Very insightful session, sir. But I am afraid that we are running behind the clock. And that was the last question that we could possibly, ask. So many thanks, sir, for sharing your insights on a topic of great importance for the industry today. I would again thank the Ministry of Steel, Government of India, for extending this support to Engage 2.0, as well as the Indian Steel Association, and of course the sponsors, JSW Steel and NMDC. Thank you, sir. Thank you very much for your very active and insightful participation in this webinar. Thank you, everybody, and good day.
Thank you.